When you have the formula of a chemical and you want to write or say its name, you need to look at the formula and see what it's made of. It's all about what it's made of. There are different rules, different conventions for different types of chemical. These are 3 of the types of chemical that there are rules for. There are rules just so that scientists can talk to each other and everyone can call the same thing the same name. It's complicated to learn the rules, but once you know them, it means you can communicate. So they're important. So we're going to look at naming acids, naming ionic compounds, and naming covalent compounds. So acids, they're pretty much anything with a hydrogen ion on them. You'll recognize them because they've got an H at the front. HCl, hydrochloric acid. H2SO4, sulfuric acid. HF, hydrofluoric acid. HNO3, nitric acid. Ionic compounds, a metal and a non-metal, or a metal and a polyatomic ion. A covalent compound where you've got 2 or more non-metals. So, just to make sure you've got it, if you need to know whether it's ionic or covalent, ionic compounds have a metal and a non-metal. That's something from the left side of the periodic table and something from the right. Or there's a metal with one of those polyatomic ions. SO4 2-, PO4 3-, and so on. Nitrate, sulfate, ammonium hydroxide. If it's covalent, you've got 2 or more non-metals. So looking at naming acids, remember these are the ones with H in them, at the front usually. Look at the formula. Is it H plus an anion, like HCl? Or is it H plus a polyatomic anion, like H2SO4? So if there's just one part to the anion, that's the negative ion, then it's one of these. And all you do is you take the root of that anion, like so in HCl, that's hydrogen chloride. So the chlorine, chloride, we want the chlor bit. So we say hydrochloric acid. See, we put hydro in front, then we put the bit of the anion, the chlor, and then we change the ending of that to ic acid. Hydrochloric acid. So there's our root of the anion. H plus an anion, we just hydro in front, ic on the end, acid. Now if we've got a polyatomic anion, we've got another choice to make. We need to look at the anion. Here we've got sulfate, SO4. That's sulfate. If it's an 8 anion, we change the ending to ic. So we say it's sulfuric acid. Now some things, the anion is ite, like HNO2. NO2 is nitrite. If it's an ite, we change it to us, O-U-S. Us acid. So we've got nitrous acid. So you got a few choices there. Alright, now then, if it's an ionic compound, a metal and a non-metal, or a metal and a polyatomic ion, we use our ionic rules. And here we've got a choice, depending on what it is. If it's a metal and a non-metal, just a simple one, like NaCl, sodium chloride on the periodic table. One from this side, one from this side. We put the name of the metal at the front, and then we take the root of the ion and change the ending to "ide." So NaCl is sodium, is the metal, chloride. MgO, Mg is magnesium, is the metal, oxide, it's oxygen, O, oxygen, changed to oxide. CaI2 is calcium, is the metal, I is iodine, iodide. So we just change the ending to "ide" and leave the metal the same. Now if it's a metal with a polyatomic ion, you need to know those polyatomic ions. You can either look them up or you can memorize them. And you just put it on the end. So here we got Na3PO4. That's sodium, Na. PO4 is phosphate. So it's sodium phosphate. Fe, iron. OH, all in 2. So we've got hydroxide. Iron hydroxide. Mg, magnesium again. NO3 is nitrate. Magnesium nitrate. So whilst these are really more complicated, once you've got the list of polyatomic ions, they're easy. Alright, now covalent compounds. I've always liked these because they actually give you all the information in the name. If you know the name, you don't have to worry about working out whether there's more pluses or more minuses and making something neutral like we did for ionic compounds. In a covalent name, they tell you what the formula is. They do it using these prefixes. Prefixes means before. So a prefix is a little word that goes in front of another word. And we use these Greek prefixes. A lot of science comes from Greek. 1, mono. 2, di. 3, tri, like triangle. 4, tetra. 5, penta. 6, hexa, like hexagon. 7, hepta. 8, octa. 9, nona. 10, deca, like decimal. So you'll see these words in math a lot. Like we've got tetrahedrons, triangles, diagonals, hexagons, octagons, decimal. So we just put that in front of our element. So there's one little wrinkle. We don't use mono on the first one. So here we've got carbon and oxygen. We've got 1 carbon and 2 oxygens. So it's carbon. It would be monocarbon, but we don't put mono in front of the first one. Monocarbon dioxide. We leave out the first mono. Carbon dioxide, because there's 2 oxides. Dioxide. Here's another example. Si2O3. So we've got silicon and oxide. So we've got 2 disilicon, 3 oxides, trioxide. There's 2 silicons, so it's a disilicon. There's 3 oxides, so it's trioxide. Disilicon trioxide. Here we've got 1 carbon and 4 fluorides. So it's carbon 4 tetrafluoride. Carbon tetrafluoride.